Not since Galileo invented the telescope over 400 years ago has our view of the universe been so transformed. In April 1990, astronauts stationed the Hubble Space Telescope in orbit, above the blurring effects of Earth's atmosphere. It returned scenes of unprecedented beauty, as well as clear, sharp images of a dynamic, changing universe. Stars, planets, galaxies, each evolving in time from birth to dissipation and death. This portrait of a universe in motion is Hubble's enduring legacy. The Hubble Space Telescope is now regarded as one of the most revolutionary scientific instruments ever built. While not the only telescope launched into orbit, it has surely been the most versatile. Spacewalking astronauts returned 4 times to upgrade its instruments to newer and more powerful technologies. As a result, Hubble has been able to probe the life cycle of stars. From their birth in nurseries of dust-laden clouds of gas, all the way to their final farewell as delicate nebulae slowly blown into space. Or as titanic supernova explosions that outshine their host galaxies. Hubble has peered into the breeding grounds of new solar systems. Dusty disks around newborn stars that may condense into planets. And it has transported us into the billions of galaxies that spread out across the depths of time and space. One of the most photogenic galaxies is a grand spiral called M74, located about 32 million light-years from Earth. Amateur astronomers have long known it as the Phantom Galaxy because of its low surface brightness. Hubble astronomers, on the other hand, saw spiral arms laced with delicate tendrils of dust silhouetted against bright ribbons of stars. These spiral arms are not like spokes on a wheel. They are density waves that move around the galaxy, compressing gas and stimulating the birth of vast waves of new stars. Using Hubble, astronomers are uncovering fascinating details within galaxies they once considered featureless and bland. NGC 1132 is an immense ball of stars some 320 million light-years away. Astronomers have concluded that this giant is the product of a gravitational feeding frenzy. Hubble showed that its surroundings are dotted with dense clusters of stars. They are what's left of galaxies that were swallowed by 1132. How galaxies grow and evolve over time is an enduring mystery that Hubble astronomers have sought to unravel. The first galaxies are thought to have formed out of clumps of gas in the early universe. These proto-galaxies came together to form larger and larger galaxies. Such galactic mergers may play out over hundreds of millions of years. Hubble has shown that it is an elegant waltz of stars and gas, choreographed by gravity on a grand cosmic stage. As the galaxies pass each other, their gravity pulls stars and gas into the space between them, building vast, luminous bridges stretching tens of thousands of light years. As the galaxies fall together again, long streams of gas and dust, known as tidal tails, wrap around their disrupted shapes. As the galaxy cores approach each other, the gas and dust clouds that envelop them can be dramatically accelerated. This results in shock waves that ripple through interstellar clouds, setting off bursts of star formation that appear as brilliant blue knots. Gravity is not the only force that can tear a galaxy apart. Hubble spotted a spiral galaxy plowing through a cluster of galaxies. There, it has encountered a vast cloud of superheated gas. Drag from this cloud is stripping away gas from the galaxy, creating tattered threads and blue tendrils. It's also pulling away streams of murky dust, as shown by the dark brown tangled region around the galaxy's center. When Hubble observations are combined with X-ray images, a bright extended fog can be seen enveloping the galaxy and streaming off into space. In the end, this encounter will leave the galaxy with very little gas and almost no chance of forming any new stars. Galaxy collisions are not always destructive. Take the case of Centaurus A, 32 million light-years from Earth. Shock waves produced by a collision have sparked an intense round of star formation, as seen in the red patches visible here. The turmoil of the collision explains the warped shape of the galaxy's disk, as seen in this wide view from a ground-based telescope. There is something else about Centaurus A that stands out. Using radio and X-ray telescopes, astronomers have spotted powerful jets blasting out of its center, and broad plumes of matter racing far beyond the galaxy. Where is all that energy coming from? Answering that question has become a major focus of Hubble observations since the day it was launched. Astronomers had long noticed that the centers of large galaxies are unusually bright. They speculated that there must be some kind of massive object lurking there. Could these objects be dense collections of stars? Or are they a breed of supermassive black holes? Millions or even billions of times the mass of our Sun. Hubble's search for the answer began in the center of a giant nearby galaxy, M87. Astronomers saw that its color was not quite the same on both sides. One side was shifted towards blue, and the other towards red. a hint that it must be rotating very quickly. This is because the wavelength of light is changed by the motion of whatever is emitting it. This is also known as the Doppler effect. Think about how the pitch of a train whistle drops as it races past. Similarly, if something in space is moving towards you, the wavelength of its light gets squashed, making it appear bluer. If the object is moving away, its light gets stretched, making it redder. By measuring how much the colors had shifted from one side of the disk to the other, astronomers were able to determine its speed of rotation. It turned out that this disk was spinning at a rate of hundreds of kilometers per second. Astronomers concluded that an object must be lurking in its center that's at least 4 billion times the mass of our Sun, a supermassive black hole. This was a key piece of evidence in the discovery that supermassive black holes occupy the centers of most, if not all, large galaxies, including our own Milky Way. Back in the early 20th century, the young astronomer Edwin Hubble joined a larger quest to understand the scales of time and distance that define our universe. To make his measurements, he observed stars in the nearby Andromeda Galaxy, just 2.4 million light-years away. His namesake, the Hubble Space Telescope, has extended those measurements to the far limits of time and space. In its legendary deep field images, Hubble stared into seemingly blank regions of sky, revealing thousands of faint galaxies from the early days of the universe. These blotchy collections of stars are infant galaxies. Over the 10 billion years their light has traveled to reach us, some may have evolved into galaxies that resemble our own. With a supermassive black hole in its center, spiral arms, exploding stars, solar systems, planets, and perhaps even life. Hubble has shown that our Milky Way galaxy is a dynamic cosmic laboratory. Some of its most striking and beautiful images are giant structures known as nebulae. This one is nicknamed Horsehead, after its clear and curiously familiar shape. Rising from a sea of gas and dust, this so-called dark nebula is a cold, dusty cloud set against a background of glowing gas. Then there's the famed Eagle Nebula, nicknamed the Pillars of Creation. A group of hot young stars is scouring these luminous towers with fierce winds of energetic particles. Dense pockets of gas resist these winds. Within them are cocoons of gas and dust, where new stars are being born. You can see the same process underway in the Monkey Head Nebula, about 6,400 light-years away in the constellation of Orion. The Monkey Head is a stellar nursery with all the ingredients needed for star formation. Its peaceful beauty masks the violent events within it. In places where stars are able to form at high rates, Hubble astronomers have zeroed in on the moment of birth. One team has been collecting high-resolution Hubble images of energetic jets of matter being shot from newborn stars. Unlike most astronomical phenomena, which can appear motionless over centuries of time, these jets visibly change on human timescales. Using Hubble, astronomers can see knots of gas brightening and dimming. This shows that these jets are not being launched in a steady stream. Rather, they are racing out sporadically in clumps. The irregular structure of these jets is likely caused by material that periodically falls onto an infant star. This image shows how violent the end stages of star formation can be. In the constellation of Cygnus, a few thousand light-years away, lies a compact star-forming region called S106. A young star named S106IR is being born at the heart of the nebula. In the final stages of its formation, the star is ejecting material at high speed, disrupting surrounding clouds of gas and dust. 3D visualizations show the extent to which the star has carved its surroundings into a complex shape, including hollow cavities. At the outer edges of these cavities, the gas has been compressed into shock fronts. The material spewing off the star not only gives the cloud its hourglass shape, it is heating it up to temperatures of 10,000 degrees Celsius. The star's radiation excites the gas, making it glow like a fluorescent light bulb. A star is born when pressure and heat in its core cause hydrogen gas to undergo nuclear fusion. The heat generated by this process pushes outward, countering the inward pull of gravity. From the violence of their birth, most stars spend their lives shining in relative peace, gradually using up the hydrogen fuel that makes up their cores. Smaller, cooler stars are incredibly efficient. A red dwarf with 10% the mass of our Sun can burn for 10 trillion years, almost 1,000 times the current age of the universe. By comparison, larger, hotter stars like our Sun burn more quickly. At about 5 billion years old, our own Sun has gone through half its expected lifespan. By observing stars similar to the Sun, scientists now have a good idea of what will happen to our solar system in the distant future. The Sun will grow steadily hotter, causing it to swell into a so-called red giant. When the Sun does this, it will destroy the inner planets of the solar system. Next, the outer layers will puff out, forming a dense cloud of gas and dust that will obscure the visible light from the star. In this stage, it forms a protoplanetary nebula. Only dim infrared emissions from the dust cloud and reflected starlight let astronomers see anything at all. Hubble images of this stage show a wide variety of shapes, hinting at the complex dynamics at work inside. The spiral structure of this nebula is particularly unusual and is likely due to a second orbiting star that is producing swirling patterns in the gas and dust. Over a period of a few thousand years, radiation from this hot remains of the star excites the gas in the nebula, causing it to glow. The once faint nebula now becomes a bright and mysterious cloud called a planetary nebula. This type of nebula populates our galaxy with luminous shapes that draw the gaze of many a skywatcher. Eventually, planetary nebulae fade to nothing as their gas and dust diffuse into space. All that remains is the tiny white dwarf, a form that our sun will take billions of years from now. Planetary nebulae are more than just beautiful shapes that grace our galactic skies. They show important stages in the life cycle of stars and how they interact with and even shape their surroundings. Hubble has given astronomers the sharpest views yet of these ghostly, dynamic structures. Take the Ring Nebula, just over 2,000 light-years away from Earth. From Earth's perspective, it looks like a simple elliptical body with a fuzzy boundary. But Hubble observations show that the nebula is shaped more like a distorted donut. The donut hole may look empty, but it is full of lower-density gas that stretches toward and away from us, creating a shape a little like a rugby ball that's been slotted into the donut's hole. The space surrounding the nebula is turbulent and full of knotty structures that formed long ago. If we were able to rotate the Ring Nebula by 90 degrees and view it side-on, it would look more like the nebula M76, also known as the Little Dumbbell. In the act of dying, sun-like stars cast most of their mass out into the galactic winds. In time, the atoms in our own sun may well be swept up into new suns, new solar systems. In the cycles of star birth and star death, the galaxy is dominated by a rare and extremely violent breed. Stars 10 times the mass of our sun, and even larger, burn hot and fast. Intense temperatures and pressure ignite nuclear fusion reactions in their cores. Hydrogen gas turns to helium, oxygen, carbon, calcium, silicon, all the way to iron. The outward pressure from heat radiating from the star's core is no longer enough to hold it up under the crushing weight of these elements. Gravity wins the battle, and the star's core collapses inward. That produces a shock wave that races out through the star's volume and obliterates it. Of the 200 million odd stars in our galaxy, one goes supernova about every century or so. The last one to be seen in the Milky Way was observed by the astronomer Johannes Kepler in 1604, just 5 years before the invention of the telescope. The most famous supernova in recent years appeared in 1987 in the Large Magellanic Cloud, a dwarf galaxy just above the plane of the Milky Way. It was so bright, it was visible to the naked eye. Launched 3 years later, Hubble has been tracking the evolving spectacle for over a quarter of a century. Astronomers have marveled at the complexity of the explosion, including the patterns etched by its expanding shockwave. Even though a supernova is only bright for a short period of time, the dusty clouds it leaves behind can last for millennia. Their effect on the surrounding interstellar gas lasts even longer. Although no supernova in our galaxy has ever been observed with a telescope, plenty of supernova remnants have been. Hubble's sharp images of their complex structures help explain the sequence of events, as well as the profound impact these explosions have on the galaxy. Take the Crab supernova, one of the most interesting and most studied objects in all of astronomy. Japanese and Chinese astronomers witnessed the explosion in the year 1054. The filaments shown in these images are the tattered remains of the star, consisting mostly of hydrogen. The collapsed core of the star embedded in the center is barely visible in this Hubble image. Yet you can see its effects. The bluish glow comes from electrons whirling at nearly the speed of light around magnetic field lines that extend from the star's collapsed core. Astronomers have been poring over the nebula itself, still growing at a rate of 1,000 kilometers a second. What they've found is that the filaments of matter that roared out of the blast contain large volumes of dust, an array of mostly carbon or silicate compounds that absorb visible light. These solid particles are crucial for the formation of solar systems. Within the Crab Nebula, there is enough dust to make 30 to 40,000 Earths. Galaxies all around the universe bear witness to the dusty legacy of countless supernovae. The bright central region of the famous Pinwheel Galaxy, for example, is surrounded by dark, dusty lanes. In spiral galaxies, hot winds from exploding stars have helped push those clouds toward the periphery, as well as above and below their flat disks. You can see evidence of this in our view of the Milky Way galaxy. Dark dust lanes and ominous clouds dominate our view into the disk, while tendrils of dust reach far above it. Some dust clouds are destined to light up with new stars, as you can see in one of the Milky Way's small companion galaxies, the Large Magellanic Cloud. Its most dramatic feature is the Tarantula Nebula, a bright region of glowing gas and energetic star formation. The tarantula, shown in these Hubble images, glows brightly because hydrogen gas within it is being excited by ultraviolet radiation from newborn stars. In a wider view, the luminous Tarantula Nebula stands out from its host galaxy. It is the brightest known star-forming region in the local universe and one of the most attractive spots in the night sky. Thanks to Hubble, there is a place within our own galaxy where you can see not only stars, but solar systems being born. In the constellation of Orion the Hunter, just under the three stars that make up its belt, is the majestic Orion Nebula. It draws our attention for its beauty and mystery. Ancient civilizations saw meaning as well, including the Maya in what is now southern Mexico and northern Central America. In their story of creation, 3 of the brightest stars in the Orion constellation represented a hearth. The nebula was the fire that warms it. At 1,500 light-years distance, it's one of the best-known examples of a star-forming nebula. A swirling cloud of gas and dust where stars begin their journey of life. Within it, Hubble astronomers discovered isolated pockets of gas called proplyds. These are protoplanetary disks that form around newborn stars in spinning mixtures of gas and dust. These disks are now thought to be planetary systems in the making. The brightest star in the Trapezium star cluster affects the nearby disks by heating up the gas within them, causing them to shine brightly. The excited material produces many glowing cusps that face the bright star. Other interesting features enhance the look of these captivating objects, including jets and dramatic shock waves. They are formed when the stellar wind from the nearby massive star meets gas in the nebula. The interaction produces shapes like boomerangs or arrows. In one case, the shockwave makes the proplyd look like a space jellyfish. The powerful radiation that allows us to see these shapes also threatens their existence. Once heated up, the disks are more likely to dissipate and dissolve, destroying their potential to spawn planets. Some of the bright proplyds are doomed to be torn apart. The dimmer ones are the most likely to survive. Among those that do produce solar systems, Hubble has been documenting a wide diversity of planets. One of them, known as HD 189733b, is a huge gas giant similar to Jupiter. It lies extremely close to its star, as shown in this animation. Proximity to the star makes its climate exceptionally hot, with temperatures exceeding 1,000 degrees Celsius. A team of scientists used Hubble to observe it as it passed in front of its parent star. While backlit in this way, a planet's atmosphere imprints its signature on the starlight, allowing astronomers to decode what is happening on scales far too small to image directly. They expected to confirm that the upper layers of the planet's atmosphere are boiling off under the intense starlight. Hubble's first observations showed no trace of this. Just before it could take a second look, the Swift satellite detected a huge flare coming from the surface of the star with powerful atmosphere-frying X-rays. When the planet slid into view a few hours later, the changes were startling. Where astronomers had seen a slumbering planet before, now they saw an atmosphere furiously boiling away. In a dramatic plume of gas, the planet was losing at least 1,000 tons of gas from its atmosphere every second. There's no life on a planet that orbits so close to its parent star. Such planets, however, are allowing Hubble astronomers to hone their search for Earth-like planets further out. When the planet moves between the star and Earth, Hubble has been able to capture a small fraction of starlight passing through the planet's atmosphere. Astronomers are looking for a hydrogen-carbon compound called methane. On Earth, it's produced by a combination of natural and man-made sources, including fossil fuel production and livestock. On this hot Jupiter, methane is probably produced by a complex chemical process in its atmosphere. Astronomers plan to use data to identify prebiotic molecules in the atmospheres of planets in the habitable zones around other stars, where more moderate temperatures would allow liquid water to flow. The new measurements are an important step toward the ultimate goal of identifying the conditions, such as temperature, pressure, winds, clouds, and chemistry, on planets where life could exist. Astronomers have detected a wide range of planets around other stars by looking for clues, like the wobbling motion of a star as a planet orbits it, or a star getting dimmer as a planet passes in front of it. Hubble was able to capture, for the first time, a direct image of a planet. Visible from the southern hemisphere, Fomalhaut is relatively close, at around 25 light-years away. It is 15 times brighter than the Sun and much hotter. This star is blazing through its hydrogen fuel supply at such a furious rate that it will burn out in only 1 billion years, 10% of the lifespan of our star. Its most interesting feature may be a large disk of dust and gas that surrounds it. This strange ring is not exactly centered on the star. Astronomers suspect that the gravity of another body, perhaps a planet, is pulling it out of shape. The suspected planet is a dim speck. To see it, astronomers used an instrument called a coronagraph to block the star's light. Then they gathered a host of clues to find out what it's like. For one, the shape of the disk hints that the planet is at most 3 times the mass of Jupiter. For another, the planet is much brighter than expected for an object of its size. That means it could have an enormous ring system that reflects starlight in all directions. One day, the material in these rings may even coalesce to form moons. Hubble is part of a larger quest to discover and understand solar systems, including our own. Among the highlights, astronomers have used Hubble to track the changing climate of cloudy Venus. Dust storms that sweep across the planet Mars. The aftermath of comet Shoemaker-Levy's collision with Jupiter. Saturn's stunning rings and moons. Uranus's rings. And Neptune's intense, turbulent atmosphere. In our solar system, few Hubble images compare to its views of Saturn and the fluttering aurorae that light up its poles. Scientists created a movie from data collected over several days during January and March 2009, when the rings appeared edge-on and both poles were visible to us. The Sun emits a wind of particles that reaches all parts of the solar system. When this electrically charged stream gets close to a planet with a magnetic field, like Saturn or the Earth, the field traps these particles. The magnetic field is stronger at the poles, so the particles tend to concentrate there, where they interact with atoms in the upper layers of the atmosphere. That's what creates the familiar nighttime glow we know as the northern and southern lights. Saturn's auroras are not only charming features, but they might teach us something about our own planet and its magnetic field. Beyond Saturn's dancing lights, or the sudden explosion of a star, the universe appears unmoving against the ponderous march of cosmic time. Among its greatest achievements, the Hubble Space Telescope has been able to track the large-scale motions of the universe. Take an event close to home. Astronomers have long known that the Andromeda Galaxy, currently 2.5 million light-years away, is moving toward our Milky Way. A team of astronomers used the Hubble Space Telescope to find out how fast the two galaxies are moving and whether there will be a head-on collision. They tracked the motion of stars in Andromeda, then projected their movement into the future. Based on these findings, they showed the course of events over the next 8 billion years as the galaxies move closer, then collide, and gradually merge into a new, larger galaxy. If you could wait a few billion years, our night sky would change dramatically. As Andromeda approaches, it will loom large in the sky. Later, when the galaxies begin to merge, they will twist and distort under the pull of their mutual gravity. In time, the new combined galaxy will become an immense ball of stars, what's known as an elliptical galaxy. Even though these two galaxies each have hundreds of billions of stars in them, the stars are all relatively far apart. The chance of any two colliding is extremely small. Our Sun, born in the Milky Way almost 5 billion years ago, will follow a new path as it orbits a whole new galaxy. In the universe according to Hubble, galaxies all across the cosmos are circling each other, merging, and moving into ever larger and denser groupings. Using Hubble to survey patterns of galaxies, scientists have been able to map a mysterious substance that envelops galaxies and clusters of galaxies. This so-called dark matter adds to the gravity of these structures and has been driving their collapse over time. Because of the arrangement of galaxies, astronomers have long known that dark matter stretches out across the cosmos in a vast web-like structure. Actually observing this web has been difficult. Now, a team of scientists has used Hubble to make detailed observations of a dark matter filament, measuring its length, shape, and density. Theories say galaxy clusters form where filaments of the cosmic web meet. So the team focused Hubble on one such cluster, with a stream of galaxies moving into it along several filaments. The astronomers used data from several ground telescopes to measure distances to the galaxies within the filament mapped by Hubble, and to trace their motions. In so doing, they made the first ever three-dimensional reconstruction of a filament. It extends across at least 60 million light-years of space. From our perspective, we see it gently curving towards us, then continuing almost along our line of sight before it plunges into the back of the galaxy cluster. Observing and reconstructing the cosmic web can tell us how the universe has evolved to date. Scientists wanted to know how it's evolving on an even grander scale. If dark matter dominates the cosmos, will its gravity be enough to cause the universe itself to crash together in a heap at some point in the distant future? To find out, they searched for a type of exploding star that's visible across the cosmos. It is the product of a small burned-out star called a white dwarf that orbits a larger star. The smaller star pulls matter from its neighbor, thereby gradually increasing its mass. Finally, when it reaches a critical mass, it undergoes a thermonuclear explosion. These so-called Type 1a explosions are thought to all have the same intrinsic brightness. How bright they appear to us is a measure of how far away they are. What the scientists found is that the most distant of the explosions were much fainter than they expected. They deduced from this data that the space between Earth and those distant explosions had been expanding faster and faster. Scientists theorized that another unknown force, dark energy, is actually pushing the universe apart at an accelerating rate. This means that the universe will not collapse in a heap. Rather, it will keep on expanding forever, until all matter and energy eventually dissipate to nothingness. In our time, the light of the universe continues to rain down on Earth in torrents, a measure of the energy emitted in a constant process of creation and destruction. Hubble has led a broad effort to capture this light in telescopes stationed both on mountaintops and in space. Through their lenses, we have seen a universe that is evolving on all time scales, from the very short to the very long. In its own brief time in space, Hubble has revolutionized the science of astronomy, while inspiring untold legions of stargazers.